Hello everyone, my name is Stephen Joy Shilmla and welcome to Stephen Explains. So today we are going to learn about a very interesting topic called differentiation. Differentiation is the mathematical process of finding the rate of change of one variable y with respect to another variable. From this example, we know that velocity equals change in displacement by change in time and acceleration equals change in velocity by change in time. So here the changes are represented using the delta symbol. When the changes are extremely small, they can also be represented by dx by dt or dv by dt. As per the definition, it is generally written as dy by dx, where x is an independent variable and y is an dependent variable. So here y depends on x. Now let us see some formulas for differentiation. The first formula is d by dx of constant equals 0. As I have said earlier, in dy by dx, in place of y, if I take a constant, the entire value would be 0. Here if we see the constants 3, minus 55, sine 30 degrees whose value would be 1 by 2, here the answer to all of them would be 0 as per the given formula. Now the second formula is d by dx of x to the power of n equals n into x to the power of n minus 1. If we look at the given example, d by dx of x to the power of 4, here first we will be taking the power which is 4 multiplied by the variable x to the power of 4 minus 1 as per the formula. The final answer would be 4x cube. Similarly, in the next example, the variable might change but the process is same. So here d by dy of y cube equals, we are going to take the exponent first 3 into y to the power of 3 minus 1 and the final answer would be 3y square. Similarly here too, d by dx of x to the power of minus 3. Here we are going to take the power first minus 3 multiplied by the variable x, then the power minus 3 minus 1 and the final answer would be minus 3x to the power of minus 4. Same goes with this example. Here the exponent is 1 multiplied by the variable x to the power of 1 minus 1 which is 0 and the final answer would be 1. In this example, the power is in the form of 3 by 2, a fraction, multiplied by the variable m to the power of 3 by 2 minus 1 which is 1 by 2. And the final answer would be 3 by 2 under root m. The third formula is d by dx of constant x to the power of n equals constant into d by dx of x to the power of n. So from the first formula we learned that whenever we see a constant, the entire value would be 0. But here the constant is in multiplication with x to the power of n. So what we are going to do is, we are going to keep the constant the left side and carry out the remaining process from second formula as usual. Now from the first example, you are going to keep 3 in the left place. First write 3. Then from the second formula, the power 2 multiplied by the variable x to the power of 2 minus 1 and the final answer would be 6x. Same goes with the second example. You are going to keep the constant 4 in the left side and then you are going to write the exponent 5 multiplied by the variable y to the power of 5 minus 1 and the final answer would be 20y to the power of 4. The fourth formula is d by dx of u plus or minus v equals d by dx of u plus or minus d by dx of v. Now from the first example, the sign involving is addition. So we are going to use the formula accordingly. So d by dx of x to the power of 5 plus d by dx of x to the power of 2. Similarly, here there are two signs involved, addition and subtraction. So we can use the formula accordingly. d by dy of y cube and dy of y square and dy of y. Now on solving, taking the power 5 multiplied by the variable x to the power of 5 minus 1 4 plus the power 2 multiplied by the variable x to the power of 2 minus 1 is 1. Here taking the power 3 multiplied by the variable y to the power of 3 minus 1 2 plus taking the power again 2 multiplied by the variable y to the power of 2 minus 1 1 minus taking the power 1 and the answer would be here 1. Now the fifth one is a very important trick called derivatives of trigonometric ratios. In this, we are going to have three groups: group 1, group 2, and group 3. In group 1, sin x cos x, in group 2, tan x secant x, and in group 3, cot x and cosecant x. Now remember very carefully, for the trigonometric ratios that are starting with the letter C, always have negative sign. Now on crisscrossing group 1, for sin x we have cos x, and for cos x we have negative sin x. And for group 2, we are going to have for tan x secant x, and for secant x tan x. Here we are going to crisscross again from only secant x. Then we are going to have secant x multiplied on this both sides. And same with the group 3. For cot x minus cosecant x, and for cosecant x minus cot x. Now again we are going to crisscross from only cosecant x, and cosecant x is going to be multiplied on this both sides. Now if we look at some examples, if the trigonometric ratio starts with letter C, it is going to be minus. And on solving, d by dx of sin x would be cos x, and d by dx of tan x would be secant square x, and d by dx of cot x would be minus cosecant x square. Now the sixth formula is d by dx of u into v equals u into dv by dx plus v into du by dx. On solving the examples from the formula, first let us write separately. Now x cube into d by dx of cos x equals minus sin x plus cos x into d by dx of x cube equals 3 into x to the power of 3 minus 1, 2. Now the final answer would be minus x cube sin x plus 3x square cos x. Now looking at another example, first we write it out separately. Then on solving, y cube into d by dx of sin x equals cos x plus sin x into d by dx of y cube equals 3 into y to the power of 3 minus 1, 2, which would be the final answer. Now the final formula is d by dx of u by v equals u into dv by dx minus v into du by dx divided by v square. It is same as the earlier one, but we are going to have a subtraction symbol divided by v square. Now if you look at the examples, first we are going to write separately. Now on solving, x to the power of 4 into minus sin x minus cos x into 4 into x to the power of 3 divided by cos square x. Now this would be the final answer. Thanking you, hope you like my content, and I'll make a future video on integration, and until then see you in the next video.